Welcome to our Smart Weather presentation as part of our LEAD 2021 event. My name is Alex Olson and I'm an agronomist with FieldSmart out of Rosetown. Today we're going to talk about the Smart Weather platform and what FieldSmart has to provide. We're going to talk about what tools are required to measure weather and soil moisture data. We're going to talk about the site-specific information provided by that weather station and soil probe and what that information can help how that information can help make agronomic and management decisions through the growing season. So the tools required to collect weather and soil data. First of all, you need a weather station, also maybe called a gateway. We use both John Deere and Pestle weather stations. The weather station is basically the brains of the operation. It takes the information that is collected from the sensors in the field and transfers it to the data platform that FieldSmart uses. There are a number of different sensors that can be plugged into the weather station to read different weather conditions, such as air temperature, humidity, wind speed, wind direction, leaf wetness. One of the sensors that we use is a soil moisture probe, and this is sent out with every weather station that is going to be put in a field. We use a 1-meter John Deere probe, and it has 6 sensors in it. There'll be sensors reading soil moisture conditions at 10, 20, 30, 50, 70, and 100 centimeters. The data platform that FieldSmart uses is Crop Intelligence. Crop Intelligence takes the information that is collected from the weather station and turns it into information that can be used to make those agronomic and management decisions throughout the year. One of the big tools that FieldSmart uses is water-driven yield potential. The water-driven yield potential is based on site-specific weather information. It's also based on your soil texture, your crop, your variety, your yield target, and your fertility information. Another tool that agronomists use with producers is the crop planning tool, and this is used when we're heading into the next growing season. We can gather information, both current and historical, to make those crop planning decisions. Soil moisture data is collected in this platform, as well as the weather data, both current and historic. It is very important to note that even though a water-driven yield potential number is given, and it may be plus or minus of your yield target, it is not a yield predictor. It is simply just a tool to help make those agronomic decisions throughout the growing season. As we continue through the presentation, I'm going to touch on these in a lot more detail and show exactly what they look like on the site. So these are 2 of the main graphs that FieldSmart agronomists and the clients can use to look at their information. So the top left graph is what we call the yield potential graph. On this graph, we're given mostly weather information along with our water-driven yield potential. Our bottom right is what the soil moisture graph looks like, and this has all 6 sensors color-coded and is reading what is happening in the soil. This is the same date range for both graphs, just showing the different invariance and information that is shown through different tools on the site. So these boxes of information here will show up as you scroll along the line. So you can go back and look at his previous days information as to where the soil moisture levels were. Same thing up here on the yield potential map. You can scroll along these dots and get information about past days for weather information. So some of the main benefits when it comes to agronomy that the weather and soil information can provide is crop health, soil health, and fertility. Some management benefits are rotation planning, yield potentials, and production management. Now that we have this information and we're gathering it, we're creating a baseline for our site-specific location, both weather and soil conditions. And those weather conditions, again, are both current and historical. So now that we're collecting the data, we can go into talking about how this information is going to help us understand our crop health. So first of all, we're going to touch on soil health. It's really important to note that a third of our crop's biomass is actually located below ground. So what this soil probe helps us to do, it helps us to understand the root activity that is occurring in the soil and where our moisture is located and how quickly or how slowly absorption is happening in the soil. It also gives us an indication of when we get rainfall, was there a recharge or a top-up event, as we call it, and where was the soil recharged to? Two main factors that can affect soil health when we're talking about the data side of it is soil texture. Soil texture is basically telling us what our nutrient and water holding capacity is. We know that soil textures have very different properties if it's a clay soil or if it's a sandy soil. Crop available water also depends on soil texture as well. What the crop available water is going to tell you is it's going to tell you if your field is at permanent wilting point, if it is at field capacity, or if it's above and beyond field capacity at saturation. Crop available water, very important to note that it is not the same as total moisture in the soil. Crop available water is water available to the plant only between your permanent wilting point and your field capacity. And that range is going to change based on your soil texture, what your clay content and what your sand content is. Soil conditions can have a very large impact on overall plant health and crop health. So it's really important to know what is going on below the surface. And these soil moisture probes provide us that information. So there are two main ways to look at your soil moisture on the crop intel site. First of all is your soil moisture by depth. So this is a very similar graph to what we saw just a couple slides ago. So this is your soil moisture information from install to time of extraction. So we can see all 6 of our sensors here, and we can see how they respond to root activity as well as rainfall events. So having the spikes or recharge at rainfall events and then decrease as root activity occurs. You can tell what your crop available water is on the side and get a pretty good indication of where you are as it reflects to permanent wilting point and field capacity. Down at the bottom right here, we have daily moisture change. So this is the plus and minus of moisture at every sensor every day. So what we have here is each 6 of the sensors that are in the soil are color coded and match the graph above. What this tells us is when root activity is happening and where root activity is happening based on which sensors are showing that plus and minus. And as the roots move deeper into the soil, we can see that the daily moisture change of our deeper sensors start to change as the roots hit that level. Rainfall activities are causing a spike in this particular graph because the daily moisture change was more positive than it was negative from root activity. And then it will continue on negative with root activity. If you want to take a closer look at each individual sensor, you can actually click on the names here and select or deselect to see as many or as little sensors at one time as you like. So now that we have a understanding of our soil moisture conditions, we're going to talk about above ground conditions, so our weather conditions and then our overall crop health. The information here is what is provided daily on the Crop Intel site as well as the Crop Intel app. The weather conditions are both current and then there's also historical information provided. So where this weather condition comes in handy when we talk about crop health is disease. So we know that disease is very much weather driven. We're talking humidity, temperature, and what the conditions are in the canopy. This information provided by Crop Intel can help us make that decision to get out into the field a little bit sooner. We know that it's important to get out and spray for disease prior to seeing physical symptoms in the field, which is really hard to spray for something that you cannot see. The information provided here can give you more of an in-depth understanding of what the conditions are like in your field and whether they are favorable for disease. We can hopefully move to a more proactive rather than reactive approach when it comes to disease management when we have this information. when we talk about fertility as it relates to weather conditions, we're basically looking at, is the crop health good? Are we sitting with good conditions? Is there a potential to capture additional yield? And that's where all of this weather information can stack up to help you make these in-season decisions. So we're going to dive into the yield potential graph a little bit deeper, and we're going to look at it for an entire year. And we're going to go through at what points, what things are we looking for, and what decisions can be made at that time. So on this graph, there are a number of data points available. We will go through them here on the next slide, exactly what they look like and where they're located on the graph. So here's a snapshot of a yield potential graph. So as I said before, this box will show up when you scroll over the dots on this graph, and it'll give you all of this information as you scroll. So obviously we're looking at this field after time of extraction, so we can actually scroll future and past from the date that we're on here. So first blue line here is our crop available water. Again, only crop available. We're not talking about total moisture in the soil. The red line is our water-driven yield potential. The blue dotted line is our accumulated rainfall this year. The green dotted line is our accumulated 30-year average. The blue bar is our 24-hour rain. And the yellow bar is our 10-year rain average. So all of these sensors will react daily to what has happened in the field and the information being relayed from the gateway. Okay, to start off, we are starting at just after time of extraction. So May 19th. The top left here, there was rainfall event right after the time of extraction. We had a significant rainfall event in this field, May 20th and May 21st. So what we're looking at here is the reaction of our water-driven yield potential and our crop available water. So our water-driven yield potential is still reacting a bit from the install, but there was definitely some influence from that rain to spike that water-driven yield potential. Crop available water, however, did not have a significant increase. This is telling us likely that our soil is sitting near saturation, which means that there's not a lot of room for that soil to absorb that much moisture, therefore not adding any additional moisture to what is crop available. Oh, sorry. Bottom graph down here, we're end of May to the middle of June. So a rainfall event June 7th, increase in the water-driven yield potential, and again, not much of an increase in our crop available water, still probably indicating that our soil is sitting pretty full. Another thing to notice here early in the season is that our current accumulated rainfall is actually quite a bit above the 30-year accumulated. So we know that we're sitting pretty good when it comes to amount of rainfall already received in this field. So middle of June to the end of June. So what we're looking at here is we're still just following our crop available water line as well as our water-driven yield potential, and keeping an eye on the accumulated rainfall for this year as it compares to the 30-year average, which we're still sitting above for the current year. So you'll see the water-driven yield potential start to dip as we get into the end of June. Now, the water-driven yield potential takes into consideration what your days to maturity are and what your crop type is. So it's in the calculation already, knowing when the water use is happening for that crop and to adjust the water-driven yield potential accordingly. So that's why we start to see the dip here as we get into some strong vegetative growth in our crop. Down at the bottom here, we're the end of June to the middle of July. So you can see our crop available water is starting to dip, pretty good indication that root activity is starting to suck some moisture out of the soil there. On July 7th, we see an increase in crop available water with a significant rainfall event. So there was room in the soil for our crop available water to be bumped up a little bit. Our accumulated rainfall and our 30-year average was starting to tighten up prior to that July 7th rainfall event and then widen again after. Water-driven yield potential was also increased after that rainfall event and then continued to decrease with considering that the crop is growing. Okay, so looking here, we are the middle of July to the end of July. We know it's no surprise that July and August were really dry in many areas of the province this year, or many of the areas that we had weather stations out in. Our crop available water is continuing to decline as that crop continues to grow, and our water-driven yield potential declines as well. Towards the end of July, our accumulated rainfall and our 30-year average is tightened up again, if not equal. As we head end of July into August, again, hardly any rainfall recorded, and our 30-year average is now, accumulated rain is now surpassed our current. A small rainfall on August 8th had a little bit of a bump in the water-driven yield potential and tightened up our accumulated rain a little bit, but did not have a significant impact. So this graph here is showing this vertical line on August 16th. So this is the end of season date, and this is set based on the days maturity of your crop. After this point, the only thing that stops recording is the water-driven yield potential because the crop is no longer in that stage. It's more moving into its getting close to harvest and getting close to desiccation. The red dots or orange dots at the top are a drought or dry topsoil alert. Also not surprising since we had a very dry July and August. With minimal rainfall happening again since the beginning of August, our 30-year accumulated rainfall is starting to really separate from our current accumulated rainfall. So after time of extraction, what we're mostly looking for is any rainfall events that are going to increase our crop available water as we are looking into next season and planning for that. So this is at time of extraction. The probe was taken out of the field October 21st, and we can see that with no rains occurring, our 30-year average is quite a bit higher than our current accumulated rainfall. We still have the dry topsoil or drought warning along the top, and our crop available water is sitting low. So staying with the same topic of soil and crop health, we're going to look at soil moisture data as it relates to water use efficiency. So here is that graph again of the daily moisture change. It's a little bit larger here so we can see the different sensors and their plus and minus throughout the day. You can see that here in June, root activity has started to take off as the 10 centimeter sensor starts to record negative daily moisture changes. So there was a few rainfall events that caused a positive rather than a negative daily moisture change a couple times throughout June and July. So this trend line here is to give you a visual of what the water use efficiency for this crop would look like. So as our daily moisture change trends, we can kind of see that it follows the same curve. So now when we look at our daily moisture use for 4 of the crops that are commonly grown in our area, we can see what the water use efficiency curve looks like and when our peak water use is as it relates to our growing, what growing stage we are in throughout the season. So now when we go back to this, we can kind of visualize, which if there wasn't these rainfall events, this would be really more pronounced because there wouldn't have been a recharge in the soil. It really would have just kept diving through this soil profile and causing negative daily moisture change, a negative value throughout the month of July. So we really, it gives us an idea of where we are in consideration to the water use efficiency graphs for the crops. So our next topics are going to be really around, now that we have the information, we kind of know how to read it, or we know how to read it. We're understanding what it's telling us. What kind of decisions can we make from this? So fertility is a big one. Fertility can be made pre-season, in-season, and post-season. The decision can be made. Our decisions are going to be based on soil texture, crop available water, water-driven yield potential, and water use efficiency. So we talk soil texture. Again, we're talking about our soil's ability to hold water, nutrient and water holding capacity. So it's basically telling us what the capability of our soil is. And it's going to be very different from a clay soil to a sand soil. Crop available water. This information can be used when we're talking about in-season applications as it relates to plant health, and then also post-season fertility decisions as we're planning for next year, understanding what our soil conditions are like as we head into the winter months. Water-driven yield potential used for in-season fertility decisions as it comes to top dressing and adding a little bit more fertilizer if we have the potential to do so. Water use efficiency, understanding when the crop is using the most water, when it's most likely going to have more root uptake in the soil based on what it's telling us, what our soil probe is telling us where the roots are located based on absorption, and then comparing that to our water use efficiency as we did in the last 2 slides. So along with fertility, decision-making, and planning comes an allocation of resources. So we all know that the 4 R's are very important when it comes to sustainability of the land. So right product, right place, right time, and right rate. So there can be differences in precipitation and soil moisture, and this may require you to place resources differently than you had originally planned. This may be field to field, this may be crop to crop. So a really good tool that this provides is the ability to know if, say, you have potential in your canola based on moisture conditions in the spring, it got a little bit more rain through the season, and maybe not as much potential in your wheat. You can take possibly shift your resources to your canola crop, capitalize on that potential that's being shown because of the conditions that are currently happening in that field, and it's showing you a positive water-driven yield potential. It's really, the data given just really helps you make the decision of, are you putting the product down at the right time, at the right rate, and is it going to pay? Is this going to be a return on my investment based on the information I've given and my fertility plan? So how do I know that conditions are favorable for an increased yield potential? How do I know I have potential above and beyond what my yield target was? So in this case, we're looking at the beginning of June. And what we're looking at here is this rainfall event that occurred and the reaction of the water-driven yield potential as well as the crop available water. So you can see this rainfall in June caused an increase in our crop available water as well as an increase in our water-driven yield potential. Another thing to look at, important to note, is that it also provides our an increase in our current accumulated rainfall above and beyond our 30-year accumulated rainfall, which tells us that we're sitting in a pretty good place when it comes to rainfall that has been recorded for this season so far. So when we head to June 9th to June 23rd, what we're looking at here is where our water-driven yield potential is sitting and our crop available water. So we know, as I said before, your water-driven yield potential is going to naturally it's going to decrease as your crop moves into that more vegetative, aggressive growth and into reproductive, based on the fact of its water use efficiency. We know it's going to be using more water. We know that your water-driven yield potential will decrease as that growth period happens. So that being said, June 9th, we're still sitting at like plus 28 bushels above your yield target. So that is a pretty significant window of opportunity there to capture some extra yield. Even when we get to the end of June, we are talking above plus 16 bushels. We had a little bit of a top-up rainfall event on June 17th that caused an increase in that water-driven yield potential. But even as we sit in the end of June, we are still looking at a very good opportunity to capture some additional yield based on our weather and soil conditions. So another management and agronomy decision that can be made from all this information that we've collected is to capture yield and quality. Like we showed in the last slide, your opportunity to capture some additional yield based on the information provided from the station and the calculation of the water-driven yield potential provided by Crop Intel. Another thing that we can target is quality. So we're talking protein, grade, and then possibly capturing that market opportunity. Is there a protein premium? Do I want to spray for this? Those types of things. We also know that if we have a crop that is it has a very good opportunity of yielding above and beyond what our yield target was, we know that protein is usually sacrificed in those situations. What we can decide to do is make an application later in the season to provide some more nutrients to that crop so it can be put towards protein, and we're not having a high yielding crop with low protein. We have the opportunity and the information provided to us to make that decision to both have a high yield and capture that protein wanted by the elevator. And sometimes there's even a market opportunity to have that high protein if it's a high yielding year. So your window of opportunity in canola is going to be just after leaf development and then narrowing as we get to full flower. So you can see your best opportunity here is where the triangle is wide. And then this graph also gives an indication of what our water use curve looks like, and then when our nitrogen uptake is highest throughout the growing season. So this would be your window of opportunity for canola. Your window of opportunity for wheat is actually, you have two opportunities for protein. So just after seeding for yield, if you're looking to capture yield and protein, application window would be just after seeding and then narrowing as we get to head emergence. And this window of opportunity can be utilized to capture both yield and protein. Whereas if you're looking to just capitalize on your protein and use that window of opportunity, you can wait until just before the milk stage and then narrowing once we get to dough stage. So as that kernel starts to harden. And this can be used to capture that protein. At this point in the season, you have more information, more data, and you have a better understanding of how the growing season has evolved and can make a really sound decision on whether you want to capture protein. At this point in the season, there's also a pretty good understanding of what your market opportunity is going to be once you get that crop off the field as well. Okay, yield targets. This comes into our crop planning portion that I was talking about earlier. So what we're able to do is when you're planning for your next season, you have the opportunity to plug in what your crop is going to be. So say for 2021, what's your crop going to be? You can pick your level of productivity for the field, being low, medium, or high. And then what the site provides to you is the crop available water remaining at the time of extraction. And it also provides to you what the 30-year average of precipitation is between November and April, and then as well the 30-year average for May to August 15th. So your crop available water is set in stone. That is taken as the whole number. What you can do is you can select from 50 to 125% of your average precipitation for both your winter and your summer precipitation. So you can select basically how you want to hedge your risks. If this year we had a lot of snow, maybe you're going to call it 100%, 125, and then you're going to hedge your bets or manage your risk of what you want to target based on the in-season precipitation provided to you. So you may want to go with 75%, and you're looking at what your target range is at 75% rainfall in season with X amount of crop available water remaining and what your winter precipitation is. Soil texture also plays a factor in this because your crop available water is going to be different based on your soil texture, and then also the water holding capacity of your soil through the growing season as well. So still looking at planning for future years, we talk about rotation planning. Rotation planning when it comes to shallow versus deep-rooted crops and where the moisture is located in the soil profile. So the top left, we have a lentil crop. Lentils will absorb moisture down to 50 centimeters if it's a dry season and the root activity is quite pronounced. Majority of moisture will be taken from that top foot. So you can see this field here. This crop has a really good amount of moisture, crop available water remaining as we head into the next growing season. These values are populated at the time of extraction. As we look at this graph down here on the right, this is a canola crop. So this field, the canola roots hit the 100 centimeter depth. So this profile is dry. There is no moisture left sitting in this profile. So for example, what does this mean? How can it be used? If I'm looking at planting a wheat crop on this lentil stubble versus this canola stubble, my management practices may be very, very different. My yield targets are going to be possibly very different if I know what the crop available water is in each of these profiles. The canola stubble needs a significant amount of moisture to recharge that soil to give that next year's crop a really good opportunity. Whereas the lentil stubble needs the top foot replenished and the rest of it is sitting pretty happy. So that's just another piece of information that is going to help you make that decision going into the growing season. Or it might not. It's just a level of information that can be given to you. The interpretation you take from it is totally up to you and can be used by you in many different ways. At the end of the day, we're managing risk. More information is always better. The more information you have, the more informed decisions you can make about all aspects of your operation. This is area-specific information. It's specific to the field that's there. It's your information that we're putting in the background to give you that water-driven yield potential. It allows you to have a more accurate measure of potential bushels. Conditions are good. What does that mean? Conditions aren't great. What does that mean? and it allows us to possibly capture market opportunities, knowing what's possible for bushels out in that field and where the market is sitting. At the end of the day, we want this to provide you with a peace of mind. Farming can be stressful. Planning for your next year's crop can be stressful. The weather has always been a little bit of a mystery. Mother Nature can do what she wants. The takeaway here is to manage what you measure. Take that data and make the best decisions you can based on the in-season information provided, both weather and soil moisture. I hope today you found this very useful. For anybody that has any other questions, please don't hesitate to contact a FieldSmart agronomist. They will be able to answer all your questions. For anybody that had a weather station in the 2020 season, if you would like a little bit more discussion and understanding of what your station was telling you last year or need some clarification on things, please contact your FieldSmart agronomist. I hope you can all join us at 4 o'clock for our live Q&A. Take care.